In example 4, we're going to just transform one coordinate. And so we still need to separate our x and y's out. So I'm going to start with the y's. So anything on the outside is a y transformation, and only thing on the outside is at -5. So we're going to just do a transformation of -5. So the -3 gets bumped down -5. So we're going to end up at -8. And that's the final position of that. So I'm just going to write that down. I'm going to end up at minus or -8. And that's my final y position. Now the x's are a little bit trickier because they are backwards. And we're going to do this in two ways. So one way is just to undo this notation. So I have my notation. My notation actually gets me back to the old x. So if I want to know what happens to the transformation, I can just undo this. I'm going to subtract 10 first, and then divide by 2. And that's going to be my transformation. Okay, so this is what I actually do. So using this expression then, I can just transform that x is 4. So I go 4 minus 10 is -6, divide by 2 is -3. So there's my answer. It's going to end up at -3, -8 based on this transformation. Now we could also do this, same thing, but we could do this using the factored form. So if I use the factored form is going to look like this. So it's going to be f of 2 bracket x plus 5. And there's my factored form. So the factored form is always compress, expand first, shift last. So if I were to use that factored form then, I take the value of x equals 4, I'm going to compress. So I'm going to end up with the 4 gets compressed to 2. And then we get a shift. So it's going to be times 1/2. It's going to be left 5. So I'm going to end up at that same -3 value that I got using the other strategy. So this one here is just putting into factored form so I can do it in the specific order of compression first, shift last. So in this case here, we're going to do the same thing. We're going to transform this coordinate, and we're going to put that on the graph of the new graph here. Okay, so this one here has one transformation on the y, and that is just the absolute value. And then we have our x transformation as well. So in this case here, the point on the graph that we're going to end up with, when we do the absolute value, it doesn't do anything to this particular coordinate because that one is already positive. So it's just going to stay at 3. Now, if that was a negative coordinate, if we were given a negative coordinate to start with, we would have to transform that into the positive. So that is our y transformation. And again, we have our x transformation. So with the x, we have, again, two different ways we can do this. I can undo this notation. So this is my notation. I can undo this. I'm going to subtract 1 first. So I'm going to go left 1. And then I'm going to divide by -2, which means I'm going to compress and flip. Okay, so again, this is my description. This is what happens to the coordinate. So I start with -2. I'm going to minus 1. That's going to be -3. Divide by 2 is going to give me +3 over 2 as my coordinate. So that would be one way we can do this. An alternative, again, would be to put it into factored form. So if I were to put this into factored form, the factored form would be I'd factor the -2 out, and I'm going to end up with x minus 1/2. So this is a expansion compression first, shift last. So starting with my -2, the first thing I'm going to do is I'm going to compress by 1/2 and flip it. So I'm going to times it by -1/2. So I'm going to end up with positive, that's going to be +1. The second step is going to be shift to the right 2. So I'm going to add 1/2, and I'm going to end up at the coordinate which I already calculated, which is 3/2. Again, notice I get the exact same coordinate because these are just the same thing, but they're just two different strategies to do the same thing.